You can see the process of sensing position data by the Gearcoder, a hollow shaft encoder. For gear-type discs, you can use regular gears. For this kit, I ordered a disc from the website Miss. The outer diameter of the disc is 80 mm and the hollow diameter is 48 mm. The Gearcoder disc can be manufactured with an inner diameter of 65 mm or more when the outer diameter is 80 mm, but the maximum inner diameter is 48 mm from the site. The module of the gear tie disc is 1, and the outer diameter is 80 mm, so the number of teeth is 80. It was made of carbon steel because it should be made of a magnetic material. It should not be manufactured with non-magnetic or weakly magnetic materials, such as aluminum. Below is a video from the side and top. You can see that the center of the disc is hollow, and the center hole is large. The gap between the disc and the Gearcoder is about 0.6 mm from the center of the Gearcoder, and the tolerance is about plus 0.1 mm to plus minus 0.2 mm. The smaller the tolerance, the more accurate the sensor is, so you can set the tolerance according to the characteristics of your product. You can see a silver magnet attached to the back of the sensor's PCB. As the convex and concave parts of the disc are positioned facing the Gearcoder with the magnet attached, the Gearcoder detects the strength and weakness of the magnetic flux density and senses the precise position. Next, I will show you the changes in the position data sensed by the Gearcoder by slowly moving the gear-type disc by hand. Please refer to the video about Gearcoder on the SensorLab channel for more details, such as the video of rotating the Gearcoder with a motor. On the left is a video viewed from the side, and on the right is the result of receiving and displaying location data. This Gearcoder is a multi-turn absolute position encoder, with a maximum multi-turn count of 8 bits and a single-turn resolution of 24 bits. The maximum multi-turn count can be set to 24 bits. The Gearcoder will be mounted on the reducer of each of the 6 joints of the robot. To shorten the communication time when receiving 6 position data through serial communication by connecting 6 Gearcoders with one cable, the maximum multi-turn count is set to 8 bits. Connecting multiple sensors with one cable may be unfamiliar to you. One cable connected to the robot's controller goes to the nearest 6th-axis Gearcoder, and another cable connected to the 6th-axis Gearcoder goes to the 5th-axis Gearcoder. If connected like this, one cable connected to the controller is enough to receive position data from 6 Gearcoders. For more detailed information, please refer to other videos on my channel. When I turn it on, the LED lights up and I read the position data. The current position is multi-turn 0 count and single-turn count 50,861. Since the single-turn resolution is 16,777,216 with 24 bits, the current count of 50,861 is 1.09 degrees. I rotated the disc past 90 degrees, 180 degrees, 270 degrees, and back to its original position of 360 degrees. The multi-turn has increased to 1 count and the current position is 3.45 degrees with 160,767 counts. If you look at the error and warning bit, it is 3. When a warning or error occurs, the output bit changes to 0, and the current value is 3, indicating that no error or warning has occurred. When I rotate the disc once again, when it approaches 360 degrees, the current position data is about 16,400,000 counts, which is about 353 degrees. When I rotate the disc a little more, as it passes 0 degrees, the multi-turn count increases to 2 and the current position suddenly decreases to 14,999 counts, becoming 2.47 degrees. If I move the disc in the opposite direction, the red needle indicating the current single-turn position moves in the opposite direction. As soon as it moves, the current single-turn position suddenly increases and then slowly decreases, and the multi-turn count decreases by 1 to 1. When the disc moves near 0 degrees, the single-turn current position decreases to a value close to 0, and when it exceeds 0, the count suddenly increases to about 16 million, reaching 357.8 degrees, and the multi-turn count changes from 1 to 0. If I move the disc slightly in the forward direction again and it passes the 0 position, the current position is 4,948 counts, 0.11 degrees, and the multi-turn count is 1. Next, I will move the disc at 90-degree intervals. When the disc moves by 90 degrees, the current position is approximately 420,000 counts, which is 1/4 of 16,777,216 counts. I show the change in single-turn position data as I move the disk 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Each time the disk moves at 90-degree intervals, you can see that the position data increases by approximately 420,000 counts. When the disk moves about 360 degrees, the current position is about 24 bits or a value close to 0, and at the same time, the multi-turn changes by 1 depending on the direction of rotation. I will move the disk 180 degrees and 360 degrees in the opposite direction. As the disk moves at approximately 180-degree intervals, the current position decreases by approximately 840,000 counts. After passing position 0, the multi-turn decreases by 1 and becomes 0. Using a kit combining a large hollow disk and the Gearcoder, I demonstrate that the Gearcoder can sense the change in position when the disk rotates in both directions. What will the Gearcoder do if the disk tooth is broken or the magnet falls off while the robot is operating? When the Gearcoder operates normally, the error code is 3, as the error and warning bits are 1. I will lift the disk upward to simulate a broken tooth. The error code changes to 0, as the error and warning bits change to 0. The Gearcoder has built-in LEDs that display assembly status and error status. When an error occurs, you can see that among the LEDs built into Gearcoder, the red and yellow LEDs are turned on. When I move the disk downward, the red LED goes off, but the yellow LED stays on. The red LED indicates the current status, and the yellow LED indicates a disk assembly status in a latch state. As errors and warnings are latched, the Gearcoder continuously transmits error and warning bits to 0. To clear errors and warnings, you must reset the Gearcoder with a receiver such as a robot controller. If you subscribe and set the alarm, it will be convenient for you to watch the next video. Thank you for watching. SensorLab.